Hello. Is it audible? Hello. Is it audible, please? Can you tell anyone is gate qualified? Please. Anyone? If anyone qualified in gate examination. Okay. What we have discussed in previous lecture? What we have discussed in previous lecture? Hello. Online students. Okay. So the switches have been classified into two types on the basis of voltage blocking capabilities. Okay, unipolar and bipolar switches. Here I have given the examples. Unipolar switch example, bipolar switch example. So what is the example for the unipolar switch? What is the example for the bipolar switch? Thyristor. Okay, so on the basis of flow of current. Okay, on the basis of flow of current, so the switches has been classified into two types. One is the unidirectional and second one is the bidirectional. Okay, if current is flowing in one direction, that switch can be called as a unidirectional. It is clear. If the current can flow in both directions, that switch can be called as a bidirectional. So I have given the examples for the unidirectional switch, diode, and thyristor is also unidirectional. Okay, the current will flow from anode to cathode only. The current will flow from anode to cathode only. It is clear? The current cannot flow from cathode to anode. Okay. So this is the thyristor. This is the GTO. The current can flow from anode to cathode. There is no chance to flow the current cathode to anode. ये current flow होने का chances नहीं है. Yeah, that's why this device can be considered as a unidirectional switch. Okay. And bidirectional switch, what we have given the example yesterday, diac and triac. This is the symbol of the diac. Okay. So in this one, the current can flow from this terminal to this terminal. Yeah. And the current will flow from second terminal to first terminal. The current can flow from second terminal to first terminal, as well as the current can flow from first terminal to second terminal. So means in both directions the current can flow. So this switch can be called as a bidirectional switch. Is it clear? So Anugartha, what is meant by unipolar, what is meant by bipolar, what is meant by unidirectional, what is meant by bidirectional? Next. So today we are going to start the thyristor construction. Today we are going to start the thyristor construction. Just wait. Okay. SR is also one member in the thyristor family. So SR is a three-terminal device. SR is a three-terminal device: anode, cathode, and gate. Okay, SR is a three-terminal device: anode, cathode, and gate. We can see here the figure. SR has built-in feature to turn on and turn off. Okay, SCR is built with the features of on and off. जैसे फॉर एग्जांपल इफ यू मेड द स्विच, उसके फीचर्स का उसका वी कैन टर्न ऑन दैट स्विच, वी कैन टर्न ऑफ दैट स्विच. इज इट क्लियर? सो बट इट इज द बाय मूविंग the switch, but its SCR is a SCR is built with the features of on and off, but it will automatically turn on and it will automatically turn off by giving the signals. So no need to manually turn on करने की जरूरत नहीं है, manually turn off करने की जरूरत नहीं है. Yeah. So based on the control circuit, it will be a turn on and it will be turn off. So this SCR is built with the features of on and off. Clear? Next. So its switching is controlled by biasing condition gate input signal. So how this it can be controlled? Switch कैसे controlled होता है? Based on the signal is given to the gate circuit. Clear? For example, I will show the. Just wait. Just wait, please. Why they have given the name for the silicon control rectifier? Because it is made up of with the material of silicon. Okay, so it can made with the germanium also, but we are having an advantage than the germanium by using the silicon materials. Okay, regarding losses and on and off process and so on, etc. So we are having the advantages with the by using the silicon material. So that's why this name is the name is given for this device is silicon controlled rectifier. Silicon because the material is used. Silicon material used here, and it is a controlling device. It is a controlling device, and it will rectify from AC to DC, DC to AC, and so on, etc. So that's why they have name. They have given name for this device silicon controlled rectifier. Mostly, this device can be used in the rectifiers while converting from AC to DC. Rectifiers की use कर सकते हैं अपन AC to DC convert करने के लिए. So mostly this devices or this device is used in the rectifier, and it is a controlling device, and it is made up with the silicon material. So that's why they have given name for this device silicon controlled rectifier. Clear? So what is the construction of these thyristors? Okay, SCR is a 4-layer and 3-terminal device. Okay, SCR is a 4-layer and 3-terminal device, like as a diode. Diode कितना layers रहता है? Online students, can anyone tell please? How many layers are present in the diodes? How many layers are present in the diode? Online students, give the response. So the PN device is diode. Okay, so it is a 2-terminal device. So 2-layer. It is the diode is having the 2 layers, P layer and N layer. Okay, this device is made up with a P-type material as well as N-type material, and this P-type material and N-type material are attached together. So then it will form a one PN junction. Okay, here the junction will be formed. So what is this junction? J. It is clear? So layers are the P and N. These are the 2 layers, and junction कितने? Only one junction. Junction कहाँ form होता है? Where the two different materials are attached. So then that place the junction will be formed. It is clear? So like the same way, like as a diode, SCR is also made up of with different P-type and N-type material. Okay, so SCR is a 4 layers P N P N P N P N. This is the anode. This is the cathode, or we can say in primary scale. This okay. SCR is a 4-layer device. P layer, N layer, P layer, and N layer. This P layer and this N layer are called as the outer P layer and outer N layer. Is it right? So this layer and this layer can be called as a outer P layer and outer N layer. And this P N layer and this P layer can be called as a inner P layer and inner N layer. ये inside है ना? Is it clear? So please remember. So SCR is made up of silicon material, and it is having 4 layers PN, and it is having two outer layers. One is the P layer and another one the N layer, and it is having two inner layers. One is the P layer and another one the N layers. It is clear. So generally, what we can say, where the two different materials, one is the P type material, one is the N type material, and these two materials are attached together. Then that places one junction will be formed. So here, this is the P type material, this is the N type material. These two are the different materials. Okay, so these two are attached, or these two are formed at this place. So here the one junction will be formed. Here the one junction will be formed, and here this is the N type material, and this is the P type material. It is clear. These are also two different materials. So here also one junction will be formed. Here also one junction will be formed, and here this is the P type material. This is the N type material. Here also one junction will be formed. So how many junctions? Three junctions. So simply we can say junction J1, J2, and J3. It is clear. So simply what we can see here, this SCR is a four layers, P layer, N layer, P layer, N layer, and it is having three junctions. So simply SCR can be called as a four layer, three junction device. Okay, is it clear? So, and whatever the terminal which is having the property of conductivity, जो अपन एक टर्नल लिया है और टर्नल एक मटेरियल को अटैच किया है, तो वो टर्नल का प्रॉपर्टी क्या होना चाहिए? इट शुड कैरी द सम करंट, मींस इट शुड हैव सम कंडक्टिव प्रॉपर्टी. अगर एक टर्नल प्रोवाइड किया है, इट विल नॉट हैव एनी कंडक्टिव प्रॉपर्टी. इज देयर एनी मीनिंग? There is no meaning. It is clear. So the terminal which is having the conductive property, that terminal which is attached with the outer P layer, which is attached with the outer P layer, that is called as anode. That is called as anode. And the terminal which is attached to the outer N layer, which is attached to the outer N layer, that terminal can be called as a cathode. Okay, so sometimes some authors can represent cathode by the C also. So don't get any confusion. Yeah. So mostly we will represent with the K. So, but in some textbooks they have represent with the C. Okay. Next. So what we can say here, it is having three terminal device. No? It is a four layer. So layers are different and terminals are different. It is having three terminals. One is the anode and second is the cathode. Where is the another terminal? For controlling the power, or for controlling the voltage or current, whatever. So we are using the one more terminal, and that terminal is attached to the inner P layer. And that terminal is attached to the inner P layer. Okay, the terminal which is attached to the inner P layer, that terminal can be called as a gate. That terminal can be called as a gate. Is clear? And these are the different doping levels. This P type material is having the different doping levels, and this N type is having the different doping levels. Doping levels means majority carriers, minority carriers, holes and electrons. Okay, so all these are the, so you can go through the physics concept. So you can get the majority, what is meant by majority carriers, what are meant by minority carriers, what is meant by doping levels. Okay, so what is meant by holes, electrons. Okay, so you can go through that concept. So no need to repeat here. So if we are going to that concepts again, we will take the two lectures more. Okay, so these P type and N type, P type and type metals are having the with different doping levels. Okay, with different holes and electrons. Clear? And one more thing, these junctions are either alloyed or diffused based on the type of construction. Okay, so means what we can say, simply remember, so where the two different materials are attached together, then that place junction will be formed. Okay, just remember that point. Next point, So here you can see the construction. Please, इधर देखना. So generally, we are representing the construction of the SCR is like this. This is the inner P layer. This is the outer end layer. This is the outer P layer. So the terminal which is attached to the inner P layer, that is called as anode. So outer P layer, and the terminal which is attached to the outer end layer, it is called as cathode. And it is the inner P layer. But here they are represented like this. Okay, but the current should be flow through like this. Anode to cathode. Okay, so this is the symbol, what we can say, equivalent symbol of the SCR, PN. Okay, so next one, इसका और एक फिगर दिखा सकते हो आपको. So ऐसे भी ड्रा कर सकते हैं आप. Also you can draw like this. Clear? So gate terminal इधर प्रोवाइड किए हैं, and cathode terminal this one, and anode terminal like this. So ये ऐसे भी represent कर सकते हो. Also you can draw like this. Okay, so next is the, so simply listen. So if you want to design the circuit, okay, if you want to draw the circuit, so again and again we cannot draw like this. ऐसे draw कर सकते हैं क्या? So again and again we cannot draw like this. ऐसे भी ड्रा नहीं कर सकते, ऐसे भी ड्रा नहीं कर सकते. So simply what we can say, one symbol ड्रा करना उसका. So what is the symbol? This is the symbol of the thyristors. If anywhere, if you want to identify the, if you want to draw the thyristors, so no need to draw the all these things: P layer, N layer, P layer, N layer, gate, anode, cathode. Just draw this symbol only. Draw this symbol. Clear? See the symbolic structure of the SCR, silicon controlled rectifier. Symbolic structure of the rectifier, SCR. It is having three terminals: anode, cathode, and gate. Okay, it is having four layers: P layer, N layer, P layer, N layer, and it is having three junctions: junction J1, J2, J3. Clear? So the symbol is like this. So if anywhere if you want to draw the SCR, so just draw the symbol only. No need to draw like this. And P and PM, no need to draw like this. Okay. Next one. So already we have discussed the outer layers P and N layers are heavily doped, whereas the middle P and N layers are lightly doped. Okay. And the gate terminal is taken at the middle P layer, anode is from the outer P layer, and the cathode is from the N layer terminals. Already we have discussed. The terminal which is connected to the outer P layer is called as anode. The terminal which is connected to the outer N layer is called as the cathode. The terminal which is connected in inner P layer is called as the gate terminal. There. So the SR is made up of silicon because compared to the germanium, leakage current is in silicon. sorry, very less leakage current in the silicon compared to the germanium material. So means the silicon material is having the number of advantages than the germanium. Best, for example, one in reverse direction. When the cathode is made positive than the anode, then what will happen? The thyroid should be turned off. The thyristor should be turned off. Okay, if even though the cathode is made positive than the anode, if the current is flowing in reverse direction, then what will happening? So the thyristor may be damaged. Okay, so आप पोजिशन में फिर भी लीकेज करंट फ्लो हो रहा है, डैमेज होने के चांसेस है. Okay, leakage current may be a positive direction as well as reverse direction. Okay, leakage current जीरो होना चाहिए, अदरवाइज लीकेज करंट फ्लो हो रहा है तो लॉसेस हो जाएगा ना. अगर फॉर एग्जांपल स्विच ऑफ किया है तो करंट जीरो होना चाहिए. सो फिर भी करंट फ्लो हो रहा है, मतलब कि कहीं ना कहीं लॉसेस हो रहे हैं. सो लॉसेस इंक्रीज हो जाएगा, पावर लॉसेस हो जाएगा. सो दैट्स व्हाई, so as much as possible we have to try put the zero current when the switch is off. So as much as possible we have to maintain the zero voltage when the switch is on. So then only we can decrease the losses. So but in the case of compared with the germanium material, so the leakage current is small in the silicon material. That's why this is the main reason why why we are taking the silicon material compared to the germanium. So that's why the thyristor is made up with a silicon material, and it is a controlling device, and it is used in the rectifiers. So the name is given like this is silicon controlled rectifier. Silicon controlled rectifier. Is it clear? Okay, so already what are the advantages of SR? It is compact in size, possess high reliability, have low losses. So already all the devices are same advantages. Okay, all the power semiconductor devices are small in size. साइज स्मॉल है इसलिए तो अपन पावर सेमीकंडक्टर डिवाइसेस में जाते हैं ना, पावर इलेक्ट्रॉनिक कन्वर्टर्स में. साइज स्मॉल है, प्राइस भी इट इज हैविंग द लो कॉस्ट and reliability, dynamic response is also fast, and losses is also less. So due to all these advantages, we are going for the power electronic concept. So like the same way, the thyristor is also having the advantages: compact in size, high reliability, and low losses, and efficiency is also high. Losses decrease means efficiency increase. Clear? So these are the advantages of the silicon controlled rectifier. So this is the simple just overview of the construction of the thyristor or SCR. Okay, SCR is one member in the thyristor, but sometimes mostly we are calling it a thyristor or SCR. Okay, mostly we are calling it SCR की जगह thyristor बोलते हैं, thyristor की जगह SCR बोलते हैं. बट thyristor में बहुत सारे डिवाइसेस है, DAC, ट्रैक, GTO, ओके, एंड SATS. पर जहां पर SCR है उसको thyristor भी बोलते हैं और SCR भी बोलते हैं जनरली. क्लियर? नेक्स्ट. Okay, so before going to turn on of the SCR, how the SCR will turn on. Okay, so just be discuss one or 2 minutes about the SCR, how the SCR will turn on. It will take 2 or 3 lectures. Turn on methods of SCR. But ask time का है. Just look into it. What is this? This is not a. This is the gate terminal. Or a gate terminal. Okay. So this is the P layer. This is the N layer. This is the P layer. This is the N layer. Okay, these are the having different doping levels. It will be represented by plus like this P plus and N plus. Okay, P minus N minus. Okay, heavily doped means represented by P plus. Heavily material is doped means N plus. Lightly doped means P minus. Lightly doped means N minus. Like this. So whatever we will can go through this concept. How the SCR will be turned on? कैसे turn on होता है? First condition is the we have to give some amount of voltage, to the anode and cathode. Here, positive terminal is connected to the anode. Positive terminal of the supply is connected to the anode, and the negative terminal of the supply is connected to the cathode. Is it clear? So here, to flow the current, so current कैसे flow होता है हमेशा? Positive to negative और negative to positive. करंट कैसे फ्लो होना चाहिए? इस डायरेक्शन में करंट फ्लो होना चाहिए ना. सो पॉजिटिव टू नेगेटिव आने तक कुछ ना कुछ क्लोजर सर्किट तो होना चाहिए ना. फॉर एग्जांपल we are having the one water tank. ये यहाँ पे पूरा पानी भरा है, पानी भरा पूरा है. सो इधर पानी फ्लो होने के लिए इधर तो जो गेट्स प्रोवाइड किया अपन, गेट रहता है ना. सो ये गेट जब ओपन होगा तभी करंट पानी फ्लो होगा ना. क्लियर? जब गेट ओपन होगा तभी पानी फ्लो होगा ऐसे. क्लियर? सो गेट ओपन होने के लिए यहाँ पे क्या करना है? तो यहाँ पर गेट इज नथिंग बट जंक्शन. सो जंक्शन फॉरवर्ड बायस होना चाहिए करंट फ्लो होने के लिए. To flow the current from P type material to the N type material. Okay, to flow the current from P type material to the N type material, the junction should be a forward bias. The junction should be a forward bias. Junction forward bias कब होता है? When the junction will become a forward bias. Negative. Exactly right answer. Respective junction form है इधर P type material है, इधर N type material है. So with respect to this junction, the P type material should be connected to the positive and the N type material should be connected to the negative. Then this junction will become a forward bias. If this junction is forward bias, then the current will flow from P type material to the N type material. This is the one point. It is clear? Just wait. Any doubt, please, online students? Online students, please. Any doubt? Okay. Next condition. Just remember the basics. Okay. So if this basics is clear, then we can go for the turn-on method. यहाँ पर देखो, what is the junction J1? What about the junction J1? Forward bias or reverse bias? Forward bias, because with respect to this junction, this P type material is connected to the positive and the n-type material is connected to the negative side. So there is no problem. This junction is become a forward bias. So the current can comes to the at this place. Okay. Next, current यहाँ तक आ गया. So वाटर इधर गेट ओपन हो गया. So फिर इधर आ गया. इधर एक और गेट है. एक और गेट है इधर. So इधर आने के लिए फिर this gate is also should be open ना. This gate is also should be open. So to open this gate, so this gate is this junction should also become a forward bias. If it is a reverse bias, this junction will not be open, or this gate will not be open. Just I am giving the example. Okay. So in order to make this junction forward bias, so we have to connect. So what? So see here, junction J2. What about the N-type material? N-type with respect to this junction. With respect to the junction J2, the N-type material is connected to the positive, and P-type material is connected to the negative. So what about this junction? Junction J2 is the forward bias or reverse bias? Reverse bias. Because with respect to the junction, the N-type material is connected to the positive and P-type material is connected to negative. So obviously it will become a reverse bias. So if it is a reverse bias, so is there any chance to flow the current from this N-type material to the P-type material? There is no chance. Clear? Next one. So यहाँ पे क्या होगा? Break होगा. Break हुआ ना? This junction is become a reverse bias. So there is a break here. So there is no chance to flow the current from N-type to P-type. Next one, junction J3. Junction J3. So with respect to this junction, P-type material is connected to the positive and N-type material is connected to the negative. So what about this junction? Junction J3 is the forward bias. So there is a chance to flow the current from P-type material to the N-type material. लेकिन but यहाँ से current तो आना चाहिए ना, वहां से आना चाहिए ना, वहां से जब परमिशन मिलेगा तब इधर तो फ्लो होगा, क्योंकि उधर ब्रेक किया है, इधर फॉरवर्ड बायस हो तो भी कुछ फायदा क्या है? देयर इज नो यूज. सो whatever the reverse bias junction is formed at the junction J2, so that should become a forward. So how we can make this reverse bias junction to the forward bias junction? So by giving the injected the current to the inner P layer, by injecting the current into the inner P layer. So how we can inject current into the inner P layer? By applying the some amount of voltage to the gate circuit. Is clear? This is the positive and this is the negative. Some voltage apply करो gate circuit को, तो क्या हो जाएगा? अगर स्विच प्रोवाइड किया आपने तो स्विच क्लोज किया तो क्या हो जाएगा? करंट फ्लो हो जाएगा. व्हाट विल हैपनिंग? द करंट इज फ्लो थ्रू द गेट टर्मिनल. इफ द करंट इज फ्लोइंग थ्रू द गेट टर्मिनल, देन व्हाट विल हैपनिंग? सम currents are injected to the inner P layer. Okay, so current inject क्या हो जाएगा? Whatever the reverse bias junction, if this current or voltage is increased, whatever the reverse bias junction is formed, and that is going to be decreases. तो वहां पे वैलेंस बैंड, यहाँ पे क्या होता है? वैलेंस बैंड फॉर्म होता है. क्लियर? फॉर एग्जांपल, सो दिस इज द यहाँ पर एक पॉजिटिव नेगेटिव ऐसे, सॉरी पॉजिटिव नेगेटिव, यहाँ पे पोटेंशियल फॉर्म है, लेकिन यहाँ पे एक विड्थ है करंट फ्लो होने के लिए, तो ये विड्थ को फिनिश करना पड़ता है. सो व्हाटएवर द वैलेंस बैंड इज फॉर्म, दैट शुड बी डिक्रीजेस. व्हेन दिस वैलेंस बैंड इज फिनिश्ड, देन द करंट विल फ्लो फ्रॉम दिस टू दिस सर्किट. So how we can this finish the valence band or reverse bias junction to the convert into the forward junction? So by injecting the current layers to the inner P layer, and by increasing this currents or by increasing this voltage to the gate circuit, then what will happen? At one particular voltage level, whatever the junction is formed, whatever the width is formed, that width is going to be decreased, and at one particular voltage level, the width is totally finished, and the path will be formed. The path will be provided to flow the current from this to this one. It is clear? जैसे आप यहाँ पे रिवर्स बायस जंक्शन हो गया, यहाँ पे पानी फुल छोड़ दिया, वाटर फुल छोड़ दिया प्रेशर से, कहीं ना कहीं एक प्रेशर में क्या हो जाएगा, गेट ओपन हो जाएगा ना, क्योंकि उसका कैपेसिटी कितना है, 1000 लीटर तक कैपेसिटी गेट है। अगर आपने 10,000 वाटर छोड़ दिया तो क्या हो जाएगा, वो गेट की कैपेसिटी नहीं रहती, तो ऑटोमेटिक ओपन हो जाएगा, तो टूट जाएगा। तो ये क्या हो जाएगा, गेट विल बी open. So whenever this gate open, the water will flows through like this. So like this same way, by increasing the voltage to the gate circuit, whatever the junction reverse junction will be formed at the junction J2, that will be finished at one particular voltage level. Then when it is finished, okay, then the what path will provide to flow the current from anode to cathode. So when this junction is become a forward bias junction, the current will flow from anode to cathode. The current will flow from anode to cathode. Is it clear? So this is the simple overall concept of the how the current is flow from anode to cathode. Is it clear? Okay. So again, I will repeat this concept. So if this concept is clear, so you can easily understand the concept of the turn-on methods of SCR. ये concept clear है क्या? Is there any doubt? Online students, please. Online students, any doubt? Okay, just wait. Just wait, please. वो वाला रोल नंबर जो स्क्रीन में दिख रहा है, रोल नंबर 1, 2, 5, 9, 12, 13,